So welcome back, everybody. And so I'm Elisa Uricchio. I'm a professor in cancer biology at the University in Lausanne, Switzerland. And I'm here as a representative of the EACR board member for young scientists. And I have the pleasure to chair this session. And the speaker of this session is Anders Nordahl. He is the CEO and the co-founder of Collective Minds and Radiologies, and he has expertise in medical imaging and magnetic resonance. And today for his talk is presenting argument on obstacle and solutions for efficient and standardized data annotation in cancer imaging. And then we will follow the presentation of Anders with a discussion. And then the discussion we will join with Linor Serdar Arberik and Clemens Siran. And for now, I leave you, Anders, the stage.
Super, thanks for the introduction. So I'm calling in this afternoon from the end of Europe, the northern end of Europe in Stockholm or in Sweden. And basically, I thought for my presentation, I will give you a practical guide to how we see image annotation or annotation work being done at EuCanImage. So first of all, the question, why do we need annotation? And basically, EuCanImage is a cancer project and it's based on retrospective data. So basically, the subjects of the repository, they underwent diagnostics and treatment already, and now we're reusing the data for our research purposes, which is to develop new AI tools. And basically, I think that if we go to start in the clinical scenario and you undergo diagnostic workup in radiology, and basically the result of that is a description of what you find in the images. Each patient has a few thousand images scanned, maybe at multiple time points, and you have this free text or letter radiology report, which by Professor Langlotz at Stanford, was kind of described as inadequate for other purposes such as clinical research. And so this is like some of the motivation why we need to do this. If we extend this to Europe, we also have to realize that these reports and clinical documentation is done in local language. So there is an additional complexity to problem and of understanding this. So at EuCanImage, we're focusing on cancer imaging and primarily divided into 8 use cases through liver, colorectal, and breast cancer. In total, there's a massive amount of subjects committed to the project and to the repository, almost 30,000 subjects. So a big task. Just to recap what we have learned in the previous sessions. So basically, the clinical data sets is coming from the clinical partners of the EuCanImage consortium. They are partly curated at the local site, and they're de-identified, pseudonymized, as we learned. When they arrive at the central repository, we do additional checks on the data. So this is what we in the EuCanImage call curation. We have a long-term archive for the data. It's called Eurobioimaging. And then we have a specific cloud setup for doing annotation work. So basically, the data is curated. So they are some harmonizations, minimization. And then we kind of enhance them further by doing this annotation and then use the data for AI research. when we started this journey thinking about the annotation requirements for EuCanImage, we discussed this at length. And one piece which is very important if we're thinking about annotating almost 30,000 subjects is like what it needs to be efficient and speedy to do. Since we're basically, you know, wanting to have expert input to enhance the images. So we made two examples. Let's say it takes 2 minutes to prepare the images, and then we have 5 lesions in one subject, and it takes 2 minutes per lesion, and we have 15,000 subjects. That's 300 days of 10-hour work to annotate. So quite lengthy. If we can work on that annotation efficiency, let's say instead 30 seconds preparation, 10 seconds per lesion over 15,000, then we end up at 33 days, which is a much more manageable. And then you know, when we think about annotation, so there are great tools to annotate data, but it's also pretty complex. So basically we thought that, you know, in order to make this well, we need a system where we both are capable of doing state-of-art radiology review while we annotate. And if we speak about image annotations, we kind of categorize them into detection annotations, which is basically a bounding box, like a square around a lesion. And the reason for this approach is that it's by far the fastest. So basically maybe you detect by visual inspection, and then when you have found it, it's a few clicks with a mouse of the computer, and you have made a 3D volume around your lesion. But then there are some use cases that require segmentation, and then to go image by image and draw on the image, the actual segmentation is very time consuming. So here there is the proposal we came up with is a semi-automatic, like a deterministic algorithm that helps you draw something in 3D while you're looking at it in 2D. And then obviously this is an AI project, so there's always the potential and possibility to use AI-driven annotation. So a machine basically looking at images for both detection and segmentation, really. And here it's more a question of how will it introduce more bias into the data set if we're using a machine rather than an expert, how accurate is it, etc. But this is something we're also looking at. So now we have done the work of annotating the images. Now we need to store the results. So basically here there are some different formats out in the research community, image formats such as Nifty, binary masks, etc., to kind of to know what you have annotated. For EuCanImage, we actually landed on continuing with the DICOM standard. It's by far the largest standard in the radiology space, and there is one type of annotation format inside DICOM called RT-struct. It's the primary used data format, for example, for radiation therapy, where it's all about target definition and organs at risk, etc. So it's very well suited for the type of annotation work. So this is the one we will use. And then when we have done image annotation, we also want to do classifications, and classifications can be both on the subject level, describing specifics about the disease on a subject level, or maybe more often in this case on the lesion level. So each lesion has a label, and to that label we have certain classifications, such as benign, malignant, what type of malignancy, etc. The last requirement, since the data set is so big and there is so much to annotate, we need to help each other. So we had a requirement that we would build something that was collaborative. So therefore, this solution is cloud-based, zero footprint review tool where the EuCanImage can actually both train more experts and invite more experts to help out with the curation work. So again, about the data annotations we do, on one side we have the lesion classifications, and on the other side we have the lesion annotations in the images. So on the classification side, for most of these use cases, they follow some kind of structured reporting standard that exists in radiology. For example, for breast, the Birad standard. Moving along here, this is kind of what it will look for an annotator when you start to annotate. So on one side you have the images, on the other side you have the classification. So basically you review the images, you go through the classification, and then you draw the lesion annotation. So one thing that we discussed a lot, and this is actually a pretty tricky problem, and basically, you know, clinicians or radiologists said that we will do a much better job of annotating if we have the patient history and the patient background available while we annotate. So basically the first solution we can think of is then to take the patient history, pseudonymize it or minimize it, and put it together with the images on the central repository. As you understood, this is a very hard problem. So basically, one of the proposals we are pursuing is to have a hybrid model of being central and local. And we're exploring then that on one side, the annotator will have access to the clinical archive and be able to read about the patient history. Using this salted hash technology for pseudonymization, we can then, without storing any personal information, kind of verify whether a local patient ID is the same de-identified subject on the central repository. So this way we could basically read about the patient while we annotate. The constraints of this is obviously that you cannot annotate anything that is not coming from your hospital or your data controller. Must also say that there are some local legal differences across Europe, whether this is doable or not. So if we start by looking at the breast imaging annotations and mammography, so basically here, you know, the use cases kind of requires detailed detection, and the detection work can be pretty complex. So for this use case, the annotation method in images will be a two-dimensional bounding box. So basically we will know where on a projection image we have detected the lesion. Moving on, in breast, we also have a sub cohort which is MRI imaging, and here it has not been fully decided what kind of segmentation technology to use, but we're leaning more towards the segmentation approach, where this semi-automatic tool will be used. In liver imaging, again, we will do annotations on both MRI and CT, and the liver, you know, often includes multiple lesions, and again, to save time, and since they are in shape always pretty similar, we have decided on the bounding, the three-dimensional bounding box as our primary tool. In this example, you see a CT scan in the axial, coronal, and sagittal plane with these bounding boxes around lesions. For colorectal, which maybe is the most difficult to do a good image annotation, mainly because the pathology is often, you know, spatially very different between individuals, etc. Here the thought idea is that if we go with a bounding box, we will include a lot of different healthy tissue, and maybe that will limit what our capabilities on training AI. So again, here we have decided to go with the smart draw 3-dimensional volume, which is painted on multiple projections of the image. To conclude this, and something that we're also motivated to pursue is to, in our annotation kind of pipeline, where we do reviews, etc., also add the capability to run actual AI tools that have been trained. We have several of these inside the EuCanImage consortium being developed. So basically the idea here is that we develop these AI-driven segmentation tools locally. We put them in a container template. We put them on the central repository, and they can be processed automatically with a defined input and output. And here again, we want to use the same kind of annotation data format, so we basically can have a human-machine type collaboration or interaction. So with that, I would like to finish my talk and leave it back to the moderator.
All right, thanks a lot. And so now we can join to the panel discussion. And this it will join to Anders Leonard, she's a biomedical engineer in the Institute of Investigation Sanitaria La Fe de Valencia, Spain, together with Clemens Siran. This is a professor of radiology at the Ludwig Maximilian University in Munich. And the stage is yours.
Okay, well, hi, very nice talk. I also, I have also my own comments. I don't know if we can start, I don't know, because I share with Karin, for example, some of the questions regarding, for instance, the formats. So it's true that, for example, in the pre-match project, where we have been doing more progress in the last years concerning, all the results, etc. Basically, we were actually, we consider to use the DICOM-sec to actually store the segmentations. So we have been doing this, and so far, well, from my experience on this, at the end, we kind of ended up having different opinions on how useful it was, because we had some opinions from the clinicians, then we had some opinions from the developers, we had some opinions, right, from, as you were saying, a system that would be hybrid within the workstations for the clinicians would be ideal, but this has complications, of course. And then, of course, since from the point of view of the developers, probably maybe I speak for some people here, but sometimes we end up using nifties or other formats that are not standardized. So I share with you all, my concerns about this and my ideas of how we could standardize this, or how we could make that actually this, or the way that, for example, not only going from sec to maybe DICOM struct or other ways, we could standardize this together with all the different projects.
So maybe just great reflections. I think we've been touching on all of them in EuCanImage as well. I think when we decided on the RT struct, the benefits we saw is that it basically it uses the patient frame of reference. So for some of these use cases like colorectal, often they are scanned in multiple 2D series, so in the multiple planes. So it's not really a 3D volume. But then if we use the patient frame of reference, we can still annotate on using this multiplanar approach. The second one, we thought that, okay, if we go with Nifty, we could never go back really to a patient frame of reference, but it's pretty simple to convert from the artist struct to a nifty. So I guess that was, and then I think like the short-term constraint will be that in the research arena, maybe the nifty format is more common than using artist struct. So maybe this will require, some effort from starting in the consortium to kind of develop the conversion method in between.
Okay, maybe I can just jump in with a couple of questions that come from the audience, and probably goes on the same line. And one is from Hasta Matur, mentioning that it's a very interesting talk. I was wondering, in what format do you store the annotations? Is it possible to do this directly in DCOM format, some key values pair, I think? Or do you utilize a standalone file with the details?
So basically, if you think about as one of these scans, they might have 2 or 3 or 10 or 15 data series or data volumes, and then basically when you have done an annotation, you will have an additional data series which represents then basically a polygon of what you have done in 3 dimensions, and it will be stored under the same subject and accession number as the original scan. So it will go with that. In addition, what we do in terms of storage is that whenever, when we create or store an annotation, we version it as well. So if I draw the first one and then I store it into the repository, and then we have maybe a quality control and maybe a second opinion, and someone changes it, we store it as version 2 of the same object. And then maybe it goes through an AI tool, it could become version 3 then. So basically we could, always revert back or, have multiple ones. Yeah.
Okay, so maybe may I raise my hand? It's me, Clemens. I have a couple of questions that are just very interesting. First, my congratulations to this very nice lecture. Of course, coming from a clinical oncologic background, I noticed that you're focusing on CT and MR. Is there a particular reason why you're not including additional functional data coming from, let's say, PET? As this is clinical reality, so this would be my first question.
So maybe not for me to answer the actual inclusion. I think seeing the use case and what we would like to achieve in terms of the AI outcomes, they try to touch like the big articles of radiology, and so maybe that's one thing to put in this. I think that the strategy is always also like, to the biggest extent possible, have the when there is like a PID from pathology, kind of have that inside the data set as well, etc.
Okay, and this maybe leads to a further question. So I noticed with great interest that you have a solution where you kind of offer a hybrid system where you can include clinical data. Yeah, so I'm thinking in the direction of integrative diagnostics. And as you know, we as medical imaging doctors are always undergoing great struggles if we don't have the necessary clinical information. So my question is that data only available for the segmentating colleague, or is the clinical data actually connected with the data set?
So there will be like a common data model for the repository, like the clinical data we store, and it will be decided on the use case level. So from breast mammo to breast MRI, and they include clinical parameters that make sense and has been discussed between, you know, clinical partners, AI developers, etc. And so that will be in place. The specific hybrid model I spoke about is actually more for the actual annotation step to enhance the data for the radiologist reviewing and annotating. And we thought it's somewhat of a trade-off, obviously. I mean, ideally we could kind of read in these reports and get it perfectly structured and anonymized, but we thought that was too big of a task. So this kind of is one hybrid solution that we would like to pursue. Maybe not for all use cases, but for the ones where the background is the most important.
If I may add something into the discussion concerning these questions. So I would like to say for the first question as well, for concerning the PET, I agree with you that it's not really, well, the target modality where we usually go and segment things. So far, it's true that, for example, in experience, we have never gone and try and do an AI algorithm that segments directly in the PET. So what we have been doing, usually the PET comes with an hybrid modality. So usually comes with PET-CT or PET-MR. So usually we go and first do more like a organ or region segmentation with AI on the MR and the CT. And then we would go and then with more like sub values or things like this, we would go and then segment the lesions that we would want to highlight on the PET. So in that way, we have seen that going directly to the PET, it gives lots of false positives. So sometimes, because there are many things that are, can be capturing, and stuff like that. So at the end, you end up having many false positives. So usually that's the workflow that we have gone is usually going with the CT or the MR and then going to the PET in a second step. At least that's my experience. And then in addition to what you are commenting now about the integration of clinical data, so I don't know if this could be, it maybe is in line of what you are doing in EuCanImage. So basically for us in Primage, we have used the clinical information that the clinicians have given us about the location of the tumors, because for some tumors it's true that they are always going to be in a specific location, but in some cases in Primage, for example, the tumors can be either pelvic or it can be almost in the neck. So, and it's the same time of, it's very heterogeneous. So we are using some of the clinical information to say basically, okay, we are going to use that then to segment only with a sub-region model. And also in terms of when a model, we are seeing that, okay, this model, we are automatically getting the metrics for this sort of, we segment this new case, we are getting, or we are getting some metrics for this. We actually have like, okay, for these metrics that we have for this specific region or this specific region, at the end, we are saying, okay, all these patients that maybe, or I don't know, accuracy is bad or lower, can we go and analyze in what group of patients are these located, what characteristics they have. So basically when a new patient comes and falls into this group, we might be aware beforehand that the segmentation might be bad or we might need to have more cases that look like this. So basically our model gets stronger and more robust in those cases that it's failing on. So that's somehow some ideas that we are working on to try and automatize this more and more. But yeah, that's just some suggestions.
Yeah, I don't know if Anders, you want to comment on it, or I can also jump in the conversation with some question from the audience, where it probably in line what was discussing, it's why you don't develop an automatic or semi-automatic segmentation tool or use available ones, in particular in relation to the liver, bounding boxes will not be enough for most AI tasks. So,
So great question, and we have had a lot of discussions on that. And I guess like if the segmentation is the important thing or the detection is the important thing, and I think there's two aspects to that. So I mean, if we stay with the liver, obviously we will use we'll do the bounding box where we're sure, and then we will apply AI tools, to train inside the bounding box as well. So we will kind of test both of this. In EuCanImage also, we have also discussed the aspect of bias, like when we then deliver or generate a full model, if the purpose is detection, and we have used AI to detect, what will that do to the model we're building. So the bias aspect, and maybe there is also like a regulatory aspect to that, like what will the regulatory authority think about this data set. I think that we will, you saw how big the data set is, so we're all kind of motivated to find good tools, and but I think we have taken the decision to start in parallel to annotate manually, and then maybe at some point stop and apply, for what we have trained manually, and go to an automatic approach.
Okay, I don't know, it's Clemens, Siron, you have comments or Linor on the topic?
Well, I'll gladly do so. I didn't want to take too much of the discussion time. So I think I fully agree with you, and I think it's about the quality of the annotations that will really provide the perspective for the quality of the algorithms and the training. But with regard to the way annotation is performed, so I kind of noticed that there was a mixture out of structured reporting when you touched upon Birads, for example, and the annotation. Maybe can you comment on that a little, because I haven't really figured out where that overlap is now in the project, and I'm particularly interested in it. So maybe we can discuss about that, and particularly your opener with the insufficient quality of our prosa reports, and the transfer of the information. So this, maybe you can comment again on this, and I would like to make 2 or 3 points in the follow-up. So maybe that would be particularly interesting to me.
Yeah, I mean the radiology. I mean, first of all, I think the insufficiency of the radiology report is that it's hard to interpret for the research purpose. The purpose of doing the report was to help the patient, so it's tailored around that. I think we can all agree that there are different reporting styles, maybe depending on where you work or who you serve. So that's one aspect, and I love radiology, so I will not go into a debate on that. Secondly, I think a lot of the classifications will be done on lesion level. So basically, we into this pipeline we have the subject, and then we do an annotation review. Let's say it's the liver, and inside the liver you have 25 lesions. And then basically maybe you focus on 5, and but each one of them gets first a label, like a name, and to that name we add like a structured report or classification, what type of, how we classify the specific lesion, maybe in size, etc. We have been discussing also whether we should classify the location. So because right now what is connecting the actual lesion and the classification is just this name and the data we have like we have a data file telling exactly where it sits, but there is no real way to to kind of filter the overall database on, I just want to see lesions that are located in the right liver lobe. So that has been, that is basically being discussed, but right now a little bit omitted.
I think we are discussing here about a very pivotal step in the full digitization of the radiology value chain. Yeah, because radiology always claims to be fully digitized, but it's not. Yeah, we are electrified and a little digitized all the way from the image creation and data storage. Yeah, but then we are dictating or writing a report that gets into a PDF format and at best gets printed out on a paper. Yeah, so I think this is a really pivotal step. Yeah, that's why I was asking, and I think this step from segmenting the image and automatically having a transfer of the diagnostic information into a structured report is a pivotal step. Yeah, and we have a situation at our department where we have a clinical data science group, physicists and smart people who actually are working on our own or on their own project. But we are also using a clinically available commercial tool, yeah, who offers solutions for that. And you probably may know that. Yeah, I'm not name dropping now, but it enables basically a segmentation on the image and a direct connection between the segmentation in the report, yeah, and the image. And I think this is of particular importance. So,
I'm sorry,
we have some background noise here.
Jana, can you mute yourself, please?
Okay, so I think this is something we need to address. Yeah? This is something we need to address in the value chain, and I think this is also very relevant not only for clinical applications, as you noted in the beginning of your lecture, to ensure that we are actually transferring the relevant diagnostic information to our clinical partners and not make them wary in 39%. But it's also particularly true for research applications. Such as in EuCanImage, that we really need to connect the image and the report. So I think while structured reporting systems where you have the structured report as a tree, decision tree right next to your image is a good workaround, I would always argue that a direct connection between the image and the resulting report, that you basically click in the report on the lesion that is described and the lesion lights up on the image, adds a level of interconnectivity that is even beyond that. Yeah, so that is something I'm always making a great point for, and it of course transfers all the information you noted when you segment a lesion, be it tectural features, be it the location. Yeah, is it in the left liver lobe? Is it a lymph node metastasis or is it a bony lesion? Yeah, and you know that, for example, when we're looking at therapy response, this may be of great importance because it may be in the literature that, for example, bone metastases are responding differently than soft tissue metastasis. So the level of annotation, the depth of annotation is definitely a quality sign and part of the game that will also directly influence the quality of the results when you use the annotated data.
Okay. On the line of the annotation, there is a question from the audience where they ask how you evaluate the annotation in order to see whether the annotation is good or not. And if there is a lesion missing, there is any way that you know that this lesion has not been annotated or detected?
Yeah, I think that I mean, to answer the last question first, I think the implementing this in practice. I mean, if we think about colorectal cancer, I think you could have maybe 25 really small lymph nodes or so that will be either go undetected or not be annotated just because it's so much work. So there will be focus on a few of them. I think the conclusion maybe on the annotation is that we have to ensure that we, the ones we actually label are, to spend the effort on making sure these are lesions, and be like more saying that out of the lesions in this specific subject, these 5 are really ones. So basically, maybe we're focusing more on the lesion level than the subject level in these use cases. Then maybe some of these use cases require classifications on a subject level as well, with the parameters saying that this subject had 1 to 5 lesions, or 5 to 10, or 10 to 20, or more than 20. That can be the case. Then how we check, I think for many of these lesions, the radiologist is going to be like the gold standard. Obviously, like a pathology result or so, but if there were no biopsy done, which will be for many of these patients, especially in liver and the colorectal, I guess, then the end point for us will be the radiological assessment, and basically to harmonize that, I think we can have training events, we can have subsets of the data being annotated by multiple people to harmonize, like and see. But yeah, that's real world healthcare, I guess.
Yeah, I also agree with you in the difficulty. So I don't know if you have done in some of these in EuCanImage, for example, a study like this. So we did an inter-observer variability study, having different radiologists to segment and to annotate different images. And it was quite surprising to see that actually we had in some of these the most common metrics like DICE or Jacquard or yeah, the Hausdorff distance. So some of these metrics we had values of about 0.9 in average, or 0.93, which means that even when 2 different radiologists are annotating images, so there's a big discrepancy. I mean, of course, I know that it's impossible to be 2 people independent, coming from maybe different centers, annotate the images in the same way, but it surprised me a little bit how can then we actually go and evaluate an AI model on, like, maybe we want to achieve 95%, 96%, 99%, if actually 2 radiologists are having a discrepancy about that sort of range. So it made me kind of realize a little bit that sometimes, even like I was talking to one of them afterwards saying, okay, what do you think? Is you who is right, or is the other radiologist who is right? And she was like, well, yeah, I think I'm right, but I understand why this person did this as well, because it can be confusing. So it's this sort of term sometimes. Yeah, for that, what we did is try and say, okay, we're going to have a methodology where we are going to be very restrictive. So basically saying, are we conservative in what we want to annotate, or we want to go for a more maybe restrictive way of basically you annotate what you know 100% there is a lesion, and if you don't know, you don't. So it's this sort of small decisions that at the end can play a part in deciding if an algorithm maybe at the end works 99% or maybe 90% or things like this. But it was quite a nice check to do. Yeah.
I see Emanuele is getting ready to comment.
Yes, I thank you, Leonard, for rising up the issue. I think that you mentioned the variability between radiologists. It is obvious. It is obvious because if I make a segmentation manually today for one lesion, I'm sure that Clemens will make a different segmentation. So this will alter, no, but not because you are different, because we are different. No, we are different in terms of perceptions of the lesion, also the manual tracing and so on. And that's the reason why I believe that we need to have an approach, an automatic approach. Absolutely. The automatic approach is based on an algorithm that should be always the same for all the lesions. So at the end, it's like having the same operator for all the lesions, and this guarantee a standardized approach. That will not be. Of course, we need a kind of reviewing process where the radiologists can interact with the automatic segmentation. So probably the semi-automatic approach is the best one. Is the best one that we have now. So that's my view.
I agree.
and I see. Okay, we still have 5 minutes.
Yeah, no, there is actually a question on this line about radiologists and who is going to train them, how they will be qualified or trained to do this, and how they are, since there is a manpower shortage on the radiology side. So there's a question, okay, how we're going to train the radiologists to do this, and who is going to do that?
It's obvious. It's always the youngest resident who has to do it.
The youngest resident, that's the correct, exactly, Clemens, you check the point. We have a lot of young residents ready to do that, but if I can answer, because being partner of the EuCanImage project and one of the clinical centers that will make the annotation for a lot of cases, I believe that the question of the colleague Darren Brennan is about do you have enough manpower in the project to do that? Of course we have, because we are part of an European Union project that is funded for making such work. So it's not a matter of having funding to do that. The funding, the matter of manpower is for a situation where you don't have funding. And in this case, we have funding, of course. The EuCanImage project provides funding for this type of annotation. And this is the task of the clinical partner that will have to annotate the cases using the system that is provided by Collective Mind. So the answer is simple here.
Oh, I'm sorry, Emanuele.
No, please, Clement.
I think the question is really has a very valid point, because it kind of is always the same discussion with big data and the quality of data. Yeah. So the quality of annotation, the quality of segmentation is just pivotal for the results you get later on. Yeah? And it is a huge workload. Yeah? Also, I mean, in unfunded projects at our department, and you cannot just take, the youngest resident, but obviously you need to have a level of expertise that ensures that the discrepancy, as described by Leonor, is kept to a minimum. And I think it is a wonderful idea to have several radiologists perform the same task and to level out differences in assessment, not to say opinion. And I think, Leonor, what you said earlier is just a great thing to do, to integrate, for example, the PET data, although you may not segment them, to increase your level of confidence. Is this a metastasis or not? And we know from the literature that in general there is a change in assessment somewhere between 15 and 20% when you integrate the PET data. Yeah. So in oncology, so I would always argue have trained people do the segmentation. It will directly influence the quality of your data, and integrate as many sources of diagnostic information than you can. Clinical information, pathology, yeah. So check for biopsies, but also the PET information coming from FDG, from PSMA, from the DOTA peptides. This will, I guess, just increase the level of confidence.
Okay. There is maybe a last point that some of the panelists want to raise. Not probably we can, let's say, close this session now. Thanks a lot for all the speakers on this session and the nice discussion, and we will move to the next session.